Lecture 19, do you guys believe it? Actually, no, lecture 20. 19 was the other day.
No, I think it's 19. Yeah, I think we're 21.
21? Good God, what did I screw up? So somewhere along the line I doubled up something and didn't. Oh well. We'll go with 21.
I think in lecture 18 you just kind of stuck on it.
Yeah, I have 2 lecture 18 so I think that
Oh. That would be fun. Okay. Alright, so let's do this. So we're going to finish up this problem with the beam. And I'm trying to think of a way to do this. Actually, easy way to do this, I think, is to go back to the last lecture. No.
I think the last lecture was actually lecture 18. I think we were going. That's what I had in mind.
So is it this 18? Yes. But then I got 18 up here in moments.
Yeah, 2.
Cool. All right, so let's make this one fixed before we screw that up anymore. You have that as 20.
Yeah.
Okay, then we're good. All right. I think the easy way to do this might be to snip this piece. Bingo. Cool. All right. Now I think we can make some progress here. All right. So this is the shear and bending moment diagram from the last the last part of this. So we need to come down and do the moment diagram. And let's not use that big. And don't need you at the moment. Okay, so this is going to be our moment. This is going to be in kilonewton meters. And what we're going to look for is the maximum moment here. Okay, so I'm going to put a little note here. Okay, so really at this point, we can still play with the numbers up here in the free body diagram, but we kind of got them all down here. And what we're going to look for is everything that's the area under the shear diagram is going to be the value for the moment diagram, okay? So to do this, the easiest way is to just write it out. So actually, why is that so big? Because I'm zoomed in really large today. All right. sum of the moment about A is what? We calculated that up here. Remember we did that? And that actually had a value of what, 0.2 Newton meters? Yeah. So 0.2 kilonewton meters, all right? Or 200 Newton meters, whichever way you want to put them in your system, okay? And it was, that was positive. All right. All right. So our first point how did I get positive though? That's the interesting question. Oh, yeah. All right. Got to do some drawing here first. I'm getting my head in the game. It's Friday. All right, so we got this for MA, and we called that 0.2 Newton meters. We have a reaction here, RA, okay? And then we have this value here for V, and we have this moment here, okay? And that's going to be at make sure I got everything right here. Okay, so let me get rid of you for a minute here. So some of the forces in Y are equal to 0, equal to V, which at that far point will be 2 kilonewtons, okay? Out at C, okay, is where we're heading. And we're going to do this. And this is where it's going to get fun, so bear with me here. Sum of the moments are going to be equal to 0, equal to moment at A minus the 2 kilonewtons and some distance x as we go out there, okay? And we want to know what this is going to be, okay? And it's always, I want to do this. I'll do this. Yeah, I think I'm going to do this in a very small, methodical way across this thing, but not how I'd want you to do the problem in the long run, okay? Because what I'm trying to get to the point is this line right here will always be a triangle, okay? So if it's a rectangle in the shear, your moment will be a triangle, okay? And it's because as we do this, I want to know what MA is at any given point, or actually M at any given point. Sorry, I got to get an M in there. Plus M, okay. M is equal to 2 kilonewton meters minus 2 kilonewton times some distance x, okay, across there. So x is anything going that way, okay? So as we go across that, the area is going to keep changing on us, okay? So really think of this as, wait a minute, so that was positive, that's a negative, so that becomes a negative, that becomes a positive, that becomes a positive. Cool. All right. So our MA starts down here at -2, okay? Because at MA is equal to -2 kilonewton meters plus 2 kilonewtons times 0, we got nothing, right? Well, we have nothing on the positive side. We only have the -2 kilonewtons. Yes? Okay. Now let's try this one. What were these distances? 0.3. So let's get that back in here. So we got them 0.3, 0.3, 0.3, 0.4. Okay. Now let's try this again. Times 0.1 meters. What's the answer to that? That need to be larger, Frank. Would that be a -1.8? Okay. Let's try it now. If this is at -2 kilonewton meters plus 2 kilonewtons times 0.2 meters, what's that going to be? And then as long as we're at it, let's see what M is at -2 kilonewton meters plus 2 kilonewtons times 0.3 meters. -1.6. Okay. So we got at the third one here. Okay. I just do something stupid with the math. No, not yet. But I have something else to take into account here. I don't like the way the solution comes out for this. It is what it is, though. It's not on the money. Doesn't match the author's solution, so I'm having some fun here. All right. So anyways, we do this. Let's take a look. I'm going to zoom down just a bit here for a minute. So we got those numbers. So we basically plotted this thing at 0.1, 0.2, and then at 0.3 meters from the left going to the right. Okay, so you see how that basically the shape changes as an angle. Okay, so the shortcut to this would be this. So if I know that at C we're going to be and this that game again, just before, at, and just after. Just before, it's going to be 2 kilonewtons times 0.3 with a slight minus. Okay, that's 0.6, right? So from 2 to 0.6, that would give us this 1.4. Everybody following? Okay, so we're really right there. Let me get this zoomed in a bit here and get this out of here for a minute. Let's put that over here today. Okay, so we have this line here. All right, and then we have the next area to take care of, but we changed and dropped that down by 1. Okay, so where is that going? So we got a shear force there, and we're going to pop that over, and it's going to cause something to happen to our moment diagram here. So it goes back to this. So we got the moment at A plus the shear at A, which was the reaction. Okay, so actually maybe I'll put that in as the R. So that makes more sense. And we're going to take that times some distance that we already will know. And then we have the force that's at so we're going to use the V at C now, and that's at a distance of X. Okay, and we want to know what the moment is. Okay, so again, the moment comes to this side, minus MA plus, minus RA times X, and this was a negative already, so that becomes a positive, and we got VC times X, and we can start plugging the numbers in here. So negative 2 kilonewton meters minus what was that, 1? No, RA was 2. Why am I doing RA? Because I'm getting ahead of myself. I want to skip the RA. Sorry. It's just VC times X, and it's negative 2 kilonewton meters minus the 1 times 0.3 meters. Okay, and that gives us a negative 2.3, right? No, sorry. Jeez, boy, it's been a nice, I'm going home. We got a 3 kilonewton force there, right? That was what that originally was. 3 kilonewtons, yes. 3 kilonewtons at C. 3 times 0.3 is what? Okay. I am demonstrating to you what, Frank? How confusing this can be doing this. I should have crossed the x-axis someplace. I didn't.
Also, if we put in the numbers, it's plus VCX, then it's minus VCX, so did you swap it on purpose?
Oh, no. Oh, yeah, I did, because I brought the M from the right side over. That was minus the MA reaction plus the VC.
I know, but then we started putting in numbers, you made it minus VCX.
Oh, down below. Yeah, no, sorry, that should be a plus. Here. So minus 2 plus 3 times 0.3 is, what, 0.9, right?
Negative 1.1.
Still didn't cross the axis, though. What is the quagmire we just walked ourselves into here? 0.2. Son of a pup. Yes, it is 0.2. Yeah. Well, I'm just sitting there thinking, it's like, what the heck? Because right there.
The RA.
All right. Can I start this problem over again? Thank you. Yeah, because that would get me across the axis. And this little guy here, 0.2. Wow. Does that make a difference in the world? Yes. Okay, so the M comes to this side. We got a minus M equal to MA, the existing one, minus, I'm going to do it again, Nate, 0.2 kilonewtons times X. Okay, that becomes a positive, that becomes a negative, that becomes a positive. Okay, now the little game of getting us from point A to point B. All right, so let's do it as if X is 0.1 meters, all right, so M is 0.2 kilonewton meters plus 0.2 kilonewtons, and we're going at 0.1. Okay. Oh, so before we get stupid here, that's the reason this is screwed up. Did I do these shears wrong up here? 2 kilonewtons. That's the reaction, right? No, so this shear is 2. Yes. And this needs to be this. Oh.
Use them in a little bit.
Yep, give me a second here. So that RA is that 2 kilonewtons, right? That's that uplifting force. That's the area of the rectangle up above, right? So 2 kilonewtons up. No?
I'm way more confused than when I walked in.
All for a point. A 0.2 versus 2. All right. Copy that down, and then I'm going to zoom back out. We're going to go from the broad picture again. Good thing we got 2 hours to get through this. Speaking of which, I better take the attendance, or I'm going to get shot if someone goes positive. And remember, next Monday and Tuesday are your COVID tests, but you're all not going to be here.
They sent out an email about that that left me way more confused about.
Yeah, me too. I actually called and asked, and they said, "Oh, just come next week, Mike." So the week after.
So just work out a form to exempt it, or you can come in the Monday.
Yeah.
Or you go,
It just but I just go to the non-vaccinated test on the Monday after.
So we're good to do that then?
That's what I got permission to do. So, all right.
Like, is it like permanently you don't have to get tested?
no, just, you just basically, you just get that week.
Yeah.
All right, so everybody kind of got that written down, and I'll zoom back out and we'll go over. And I am sorry, I was not trying to make you confused. I was really trying to keep this straight and orderly. Okay, let's go back up here for a minute. So the shear diagram, okay, just to go over this. We went up 2 because of the reaction at RA, right? So 2 kilonewtons was the reaction up to balance out the rest of the system. Okay? That stays constant over to C, and that goes down 3. Okay? 3 stays constant until D, and then it goes down 2 more. And that takes us over to E, and then E goes up 5, and then at E, we go all the way over to B, constant at the positive 2 again, and then down. That's what we got from there, okay? We need those forces because moments are forces times distances, right? Okay. So ideally, when we do this bit, other than we're starting with this moment up here, all right, we would normally just take this force at some distance across here, okay? So 2 times 0.1 would be 0.2, right? Except we already have the negative, or the 0.2 out here, okay? So I put it into the equation down there, all right? And then I went over to 0.2. So negative 0.2 kilonewtons plus the 0.2 this, or the 2, what? The 2 kilonewtons times the 0.2 meters would be what number now?
You said times this, so.
Yeah. What's the area of the 2 kilonewton force moved left 0.2 meters? 0.4 kilonewton meters. So far, so good? Then when I go up 0.2 and go over 0.3 millimeters, meters, I'm at a 0.6. Okay? So far with me? Okay. Now, let's take it back with the MA that was out there because we got to hold the thing against the wall. Okay? So that left me with MA minus the 0.2 kilonewtons. God damn it. Excuse my language. 2 kilonewtons. Now that's positive too. Let's rewrite this thing.
Can I go home?
Not unless I do. Sorry. All right. We got MA. All right. We have a positive R. I'm going to use VA. Okay. Which is VA is equal to RA. Okay. But that's the shear at that first point. Okay. We have to multiply that times the distance. We do know the distance. It's going to be 0.3, okay? And then we have one leftover piece out here is we really want to know the moment, okay? So the moment is what we're looking for, okay? So I got to bring the moment to the right side. So that becomes a negative. I got MA plus the VA times X at some distance. Everybody good so far? All right. Now, that becomes a positive, that becomes a negative, and just for sake of keeping the diagram straight, that looks like stupid crap. That becomes a negative. Okay? Did I do that math right? Negative MA times No, I'm not doing this right. Okay. So I don't want VA, I want VC in here. And VC is the 2, but the 3 also. Okay. So VC is 3, and that's a negative force there. And that's going to give me this. So negative 0.2 kilonewton meters that start there, minus, this is minus up here, so that's a plus here, plus 3 kilonewtons times the 0.3 meters. What do we got for a value there? Frank, you got a number? No.
I got 0.7.
0.7. Okay. like so. So what am I looking for? All right. So somewhere in your card, I'm trying to explain to you that it's an angle. I was trying to break it down in increments to work our way up, and I screwed that up. Okay. So at this point, I guess the best thing for you to remember is if it's a square or a rectangular shape for area, it's always an angle for the moment. Okay, always on an incline. Could be down an incline depending on what side of the zero is, but it's an incline. Okay. What I was trying to get you to do is see that. Okay. But we're going to look for the maximum. That's the right line. But good so far? Maybe? Yeah. You could screw it up and have a great day. Patrick chooses 10.
Yep. After watching you erase that and I saw you wrote in 10, I was like, oh my gosh.
So there's a reason engineers use pencils.
Screw ups.
No.
So, little side story here. Electrical engineers like pens for some reason because their work is always permanent, never changes. Yeah, right. But they've always done all their electrical circuits in pen, and if they make a mistake, they one line through it, right over again. No. In our world, we know we're making mistakes. So I would say we right, Carter?
Oh, yeah.
Okay, so the next one is we're here. We want to take care of this area from this over to VD, right? So this was A, C, D, E, and then B, okay? So now the next equation becomes this. Sum of the moments equal to 0 equal to M, and this is actually M at C now, okay? So I can label that. And that's what this would have been. M of C plus the V at D, right, which is -3 times that distance, okay? All right, so 0.7 kilonewton meters plus a -2, right? Yeah, 2 kilonewtons down. Times its distance is 0.3 meters. All right, so 0.7 times -2 times 0.3 is 0.6. That should give us a negative or a positive 1. 0.1 kilonewton meters, okay? So we're right there. So far with me? You sure? I don't want you like Carter over here. Confused, lost. Gonna throw up his book and go home. So far so good? Alright, what's the next one going to be? Anybody want to take a stab at it? Yeah. Hold on, let me make sure I got the moment at DE, right? And that's our M at D. What's the rest of it here? Come on. And the shear. Well, we're the E. So plus V at E times the distance that was, and that was 0.3 also. Okay. What did I miss here? No, did I get the right number? 0.1. I want to drive this down to two. Okay. I need to get down to negative 0.8 at this point. Two times 0.3, 0.1. PT was 0.7. This was 0.2, negative 2. Ooh, did we do something wrong in that shear diagram? Negative 3. I want this to be, let's see if I play this out in my head for a minute. Don't write this down, Patrick. 0.1 kilonewton meter. We got a negative VE, which is 3 kilonewtons for the VE, times 0.3 meters. And that will give me a negative 0.8 kilonewton meters, and that is the right number. But did I use that 3? I didn't use that 3. I used this 3. So, but I didn't use 2 in the right place then. I used 2 up there, 1 down here, 1 times 0.3. Negative 2 is the force, 0.3, that's 0.1, right? 0.1 is the target. And I'm missing, okay. Three down to negative 1. Negative 1 times 0.3 is 0.3. Coming from what is 2 times 0.4 is 0.8. That's right. Boy, something just looks funny in there. So if I do the last one here, so M at B is going to be equal to 0 equals, some of the moments at this is equal to ME plus the V at B times 0.4 meters minus the M at B. So M of B is equal to minus ME plus, no, minus VB times 0.4 meters. And we're going to get 0.8 negative becomes plus kilonewton meters minus 2, because that's what's hanging out down here or up above. 2 kilonewtons is the force times the 0.4 meters, and we're going to wind up with 0, which is what you should get. So literally this thing does this. Goes to and negative 0.8 kilonewton meters is the max moment. Mathematically that worked, but I think I missed something in there. Go away so people can see things. I think we're going to go do the next one without that extra moment in the beginning. Just to make life simple. Okay? Patrick's got 2 pencils out now.
I have holes for my pencils in the bag.
We definitely need to do 2 more of these, but I'm confused, maybe even myself. But that is the correct moment.
Confuse us more.
Wow. I did say this is a topic that takes about 3 weeks.
Yeah.
The stress that goes with this is easy to calculate once you get through this crap.
The personal stress?
Yeah, that's
Yeah. Now the personal stress is what's going to take you 3 weeks to get over. And then at some point you just go, I don't care anymore, and just do it. But I think I complicated this by picking one that had the cantilever, so it had that extra moment out there in the beginning. Thank God I didn't pick one with a offset load on the beam. That caused you some other moment problems. When you're doing this. All right. Break?
Yeah.
Clear your head. I'm going to go over and get an iced tea so I can clear my head. It's scary, but okay. All right, so let's take 5 to 8 minutes or so. All right.
Yeah, you both had that reaction. You okay? Wow.
Moving along.
There wasn't either when I came out.
You don't have a can of air, so we didn't break the rest of it. Yeah, look.
Oddly enough, we just happened to look for this morning because I was like, what are we gonna do with these? And yeah, I know.
Wasn't it? But I was in there till 5. And then 5. Everyone else was doing it that, but I was walking around in case. No.
Frank, did you find a couple homework problems to do?
You know, last time I don't feel like doing it anymore.
Well, anything but this last one.
Is for homework or for now?
For homework. Something that you think you might like to tackle.
I feel like 13.17 looks acceptable.
13 points.
0.17 is like A and B.
Okay. All right. Okay. What's on the left-hand end of this beam?
What's this one? that? Well, it's the left hand then, right? A, what's that A? What is that section we need? Cantilever. Yeah. Just, but it's not gonna be like the last cantilever because it's not attached to anything, it just hangs out there. Its attachment point is the rest of it. Be a little easier. Hopefully.
So Carter, you're going to be the judge. When your stress level peaks out, we want to know about it. All right. So free body diagram. What do we got? We got a beam that looks like this. Okay. We got a reaction here. Reaction at C. And we got a reaction out here at B. Okay. And we got a force here at E, which was 25 kips. And we got one here at D, which is 25 kips also. Okay. And then way out at A, okay, so one little side note here in the world of chaos. Kips is what? Okay.
Everybody tries to put 1,000-inch pound somethings, okay? They're not, okay? Just a standard designator that we use. The civils, you three will use it the rest of your life. The rest of us hate the civils for it, but it's there, so you might as well get used to it. You could fight it, or well, it's the Borg. You'll be assimilated, and they want to assimilate the mechanicals. So is it like the same as us using like ton for 2,000 pounds? Or?
Yeah, yeah, but even they don't use tons for 2,000 pounds. All right. I think it's 1,000 imperial pounds, and they put an S on the end for pounds. Okay, so it comes from the Romans. All right, so just to keep that in mind, it's 25,000 pounds on each of those points. Okay, we got our distances up above. We should be able to go for this. We do need to find the reactions though. So, whoops, let's put that back in black. Find the reactions. Okay, so sum of the forces in the Y can be equal to 0. But really, that's not a great place to start because we got two y's unknown, okay? So some of the moments about RC could be kind of cool, or you could do some of the moments about RB. Doesn't really matter, just which way do you want to go, okay? I tend to work left to right, but you could work right to left and be all hunky-dory. The cool thing is we did RB. Actually, let's do RB just because. Defy the convention. If we're going from B, everything there is continuously multiplying distances. Okay? Where if we go from C, then A's got a 1 foot one, D's got a 2 foot one, and we got to keep, that in mind as we do that. But really at this point, that is as if this point out here was B, and that whole beam just swings about that point. Okay, so choose wisely, choose it where it's easiest for you to understand it, and try not to fight it. Okay, all right, so let's do this. So about RB, so everything about this. So going this way, we have FE at 2 feet. Okay, and wait a minute, before we do this, we need a direction so we know whether it's positive or negative. So which way do you want to make the rotation moment to be positive? And it doesn't matter. Choose one. World's a happy place. But you got to choose one. Counter. Hold it, Patrick. You always went first. Him and his killer bunny. Counterclockwise. Like so. Yes? Actually, I kind of like that one. Why? This first force goes positive, right? Okay. All right. Then moving to the next one. So that's that one. Plus FD. But now we're 6 feet, 2 feet, we're 8 feet. Okay. Then we're RC. That's a minus. That one's going to go clockwise. And that's going to be 2, 4, 8, right? Or 10. Okay. And then the last one out there is F of A, and that's a positive, and that's going to be at 11 feet. Okay, everybody see where those came from? Understand them? All right. So the real simple thing is move RC to the right and solve for the rest. So RC is equal to FE, and that becomes that stays positive, times 2 feet, plus FD times 8 feet, minus, positive, sorry, FA times 11 feet, and then everything here is going to get divided by 10 feet. Yes? Okay. Reaction for that is? Oh, I guess I had to put some numbers in, sorry. 25 kips times 2 feet plus 25 kips times 8 feet plus 25 kips times 11 feet, all divided by 10 feet. Should wind up with 52.5 kips, right? Because all the feet will cancel out. Now is a good time to go do some of the forces in the Y. Or you could just skip some of the forces in the Y and do the moments about RC now and solve for RB. Okay? Either way. Most people don't, but there's a lot of points to just doing the moments and having them done. So we're going to solve for some of the forces in the Y. I always like forces in the Y to be positive going up. All right, so we got minus FA plus RC minus D minus FE plus RB. Correct? We know everything now except RB, so RB comes to this side, that becomes a minus. Leave everything alone for the moment. And then the only other thing is to make that positive, make that positive, 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 change that to a negative, and then we're able to solve for RB. Okay. Let's see, next thing. So let's put some numbers in here. So 25 kips minus 52.5 kips plus 25 kips plus 25 kips. And we're going to be equal to, what is that, 22.5? Okay.
That's the plus RB or
RB.
B. Okay. So that's an answer, that's an answer. And then on your comp paper, if you're doing it, I'd go over here and go 52.5 kips, the line RC, and 22.5 RB. Okay. So far, so good? All right, the only other thing I would do is I'd go back to your diagram once you know these and label them. Okay. Oops, missed that one. Alrighty, so our missing piece next is find the shear. And the units are this are kips. Okay. So far, so good? All right. So, at A, V of A is going to be equal to what? What's the force pushing down? It's going to cut that off. And actually, a cool way to do this too, if it helps you understand a little better, V to C is going to be what force? Say again.
So A's out there, we got a FA at 25 kips. So that 25 kips is going to push down from there all the way to just before C, right? So it's a 25.
and it's negative, okay? So literally on the diagram here, let's do it in purple. We're going down to, let's see, 5, 10, 15, 20, 25, minus 25, okay? So literally straight down. Yes? And then Patrick, where's it going from there?
Let's go over and we'll go up.
Straight to there, right? Okay. The next equation we have to write is VC to D, right? Yep. Okay. And at VC, we have a reaction of 52.5. Okay. So the coolest way to write this is this. VAC plus the force of RC. Okay. And if you take your numbers now and put them in as negative 25 kips plus the 52.5, is that what it was? You should get a 27.5 kips. So far, so good? Okay. Now, 5, 10, 15, 20, 25, 30. So we are someplace right about there. 27.5. Straight down to that one. Carry that one straight over because there's no other forces acting on it. All right. So far, so good. All right. Moving down to V, D to E. So that's VCD plus the force at E, right? No, force at D. Okay. And we got a 27.5 kips minus 25 kips. So that leaves us with a 2.5, yeah, 2.5 kips. Good, Henry? Okay. Fidel? Loge? Carter, have I lost you?
No, you're good.
Stress level is neutral right now?
Yeah.
Okay. I don't want you shearing yourself off. All right. So let's get that drawn in. Go down to here. And ideally it goes across there to there. And for the lack of anything better, I'm just going to put it there because... Okay. All right. The next piece is VE to B, correct? So that is VDE plus the force at E. Cool. All right. So 2.5 kips plus a negative 25 kips should give us 22.5 kips that are negative, correct? So I come back up here to the drawing. And the last check to this thing is really simple, but it shouldn't be too complicated. V at B is going to be equal to VEB plus the reaction at B. This should be negative 22.5 kips plus 22.5 kips. Better be equal to 0. Okay.
Now, I should move, put it in the drawing here.
So that goes back up to 0. What happens if a number doesn't come out to 0?
And it's only off by like point something. Rounding error, okay? You do want to check it, make sure you didn't make some horrible mistake. But usually when they screw up, they're not off by 0.0. They're off by 10, 100, something else, okay? So if you get to 0.0 something, it's just how you round it in the calculation. Okay? So caution there. I spent many a nights trying to figure out, how come it didn't come right to 0? So see the instructor is like, you're getting too wrapped about the axle about that.
All right, so I think for sake of space, we're going to draw some more lines vertical down through the moments. Actually, no. I think what I'm going to do is this. We're going to actually keep it running to the right over here so we can actually see these numbers while we play with this stuff. So we need a draw a line. All right, so the moment, bending moment now, and this is probably going to be what you'd see on the second sheet of the paper, of comp paper, so so don't need you at the moment, go away. All right, so now we need to figure out what the bending moment Okay, so ask the question. Moment at A, what is that? There's a force there.
Is there any distance? No, so it's 0.
Okay. So the cool part about that is when we come back over here, we start out at 0 for the moment. Okay. The moment now at C is going to be, and we went with counterclockwise, so we'll stick with that. 0, and that's going to be equal to the V at A times 1 foot, correct? Plus the moment at C. Actually, I'm going to get rid of that equal sign for a minute. Just do this. Okay. So MC is equal to a negative VA times that. Okay. Or actually, sorry, I'm using VAC, wasn't I? So far, good with me? Okay, so negative times a negative. BACC is something's horribly stupid here. 1 times 25. 25 times 1 plus that moment. We're taking the moment about C. Moment about C. We're going this way. That goes with that. Yeah. Minus, plus, that's there, cool. All right, so we're minus 25 kip feet, okay? So really, going down now, we're heading this way, minus 25, okay? Next piece, the moment at D. And once you kind of choose your moment counterclockwise, don't change it. Okay? And that's going to be equal to 0, such that 3 feet, 25 feet. Oh, wait a minute. Do this. 25, 27. Okay, this is the reaction at C times 3 feet. Oh, I get it. Hold on. Moment at C plus the reaction at C times 2 feet for that. All right. That's going to be the moment at D. Moment at D is equal to negative moment C minus RC times 2 feet. And negative moment is a negative times a negative 25 kips minus 52 . I carry that over right. That was a negative, positive. Now, this is a negative up here. Negative, positive, positive, positive. Geez, I'm getting my negative signs messed up today. Anyway, so 52.5 times 2 is 105 minus the 25. That's not right. 52.5. Oh, how'd I miss 25? That's a foot. 25, 3. Nah, there's a number missing here. It's not 25 MC. We need the 27.5. Sorry, Patrick.
Good.
3 feet, right? Because we got to get that area plus the reaction at C, which was 52. 5 kips times 2 feet. Three times 25. 2 times 25. Okay.
Oh, I lost it. Where's your stress level?
Level.
Level.
It's more confused than stress.
I think mine's right there too. Oh.
I'm saving all my confusion for next class. So. Use it all.
I messed up. It's right. They work. And somebody's already thrown count paper on the floor. Had enough of this already?